So using the CAS for Euler's method, in your textbook, there's actually a page that shows you Euler's method program for the TI Inspire calculator. And what you want to do is follow the instructions here to input that program into the calculator. Now, just to get you started in your CAS, if you open up a new document, so just the calculator, if you go into Menu, and then Functions and Programs, Program Editor, and New, you'll write a new program. You can call this something. So I've already made one of these, but I'll call this Euler 2 just so you can see. Now it's going to set up the program, okay, and you're going to need to enter in the different fields. So what the inputs are going to be and what the output is going to be in here. So you're actually coding, it's pretty cool. And if you follow the instructions here exactly, it really tells you everything. So you'd put in X1, Y1, C and H into here as the inputs. So you could, even if you want to, just copy and paste things over. I just copied and pasted that. The thing that you want to make sure you do when you build your program, before it will run, what you need to do is go into Menu and do what's called check syntax and store. Check syntax means it basically checks if what you've written makes sense, and then if it does make sense, it stores it. So if we click that, you can see it says stored success. For my program Euler 2, that means that what I've typed in here actually makes sense, so that's going to be usable as a program. So now this is the Euler program that I've written down, so I've taken it exactly as it was out of the textbook. And what we're going to do is use this now. The first thing I want to do is check what variables I have defined, because I've been working in here already. So you can see I've got a couple of variables defined. I've got the variable g defined, which I actually don't want to be defined as anything. So what I'm going to do, I'm just going to clear that. So do what's called del var. Make sure G is not actually identified as anything. So now we're going to use Euler's method using the CAS, but just going back to the work we've done already, the derivative dy dx that we worked with in that worked example is also known as g of x. So we're going to be using this function here as our g of x. We're going to use our initial conditions again, so x equals 3, y equals 0. We're going to use our step size, h, and the c in the program we're going to use is actually how far we go in x. So you can see we're just going to go up to 4 in x. So that will be the c that we have in our program is 4. So we need to put everything into the CAS. Now the important thing with this program, Euler 1, is you need to actually define, you can see it down here, what g of x is. What is the derivative function? So we do that by typing define g of x equals, and our derivative that we were looking at was x squared minus 2x. So we type in x squared minus 2x, and that's now defined. So if we were to put a value in there, say for example 2, x squared, which is 4 minus 2 times 2, which is 4, would give you 0. So it really just substitutes the value of x into your function. So you could even put like a variable in there. See, so it substitutes it in place of the x. So now we know what g of x is, we can use this function here. So Euler, use the program. So I'm going to copy this over. And this is going to output the same table that we had in our example. Our initial x was 3. Our initial y was 0. We're going to go up to x equals 4. And our step size is 0.1. The smaller the step size, the more accurate the solutions will be, by the way. So we push enter, boom, and we get out a cool table. And this table, I'll actually take a screenshot of a bit of this table, bring it back over. You can see here that the screenshot matches 3.0, 3.1, 0.3, 3.2, 0.641, 3.3, 1.025. So it matches, which is fantastic. So that means we've actually created this table using the CAS. Now if you want to, you can put a little bit more space between those values. I've just put a space here, but if you want to make that a bigger space, that'll space these values out more. So I might space the x and the y out. And then if I wanted to run that again, check syntax, store it, and that should separate the x and y out. This is just a space. Anything in brackets is just what it actually prints. So it should have spaces, spaced out my x and y a bit better. And my 3 and my 0 are a bit further apart. Okay, and I might space out down here, space these ones out a bit more too. So that's just a little bit about fixing your code. So it is nice, you can play with your code and actually make some changes to it. So what you've done there is you've used the CAS to actually recreate Euler's method using the formula in your textbook. So just as a final video, I'll actually run through, that's probably a bit too far away, those ones there. Looks good there, and then they're a bit too far away. I'll actually run through using this program to solve, there we go, it looks nice, to find solutions for a differential equation.